Okay, so this one is another problem from the homework. This is number 3. In this problem, we are starting with the general equation for the B field due to a wire. So in this general equation for the B field due to a wire, we have a phi hat direction here. So moving around the wire, which is what we found, right, for our first part here. So if I scroll up to that first problem, when we did this guy, we found out that our resulting B field was in the phi hat direction. Let me just go ahead and write that in both of those answers. So that just means that relative to the wire, the B field is rotating around the wire. So I'm getting lost here, sorry. So relative to the wire, if we're modeling it in the z hat direction, our B field is rotating around in the phi hat direction. That's all that means there, okay? So for our coordinate system, for this problem, we are not in cylindrical, so we're going to have to keep that in mind at the end. But we're going to do a couple of things before we do that. So we have B field due to a wire, and then we have a square here, okay? So we need to find L, which is going to be the length of the wire, and then we need to find our R, which is going to be the distance from the wire to the point that we're measuring at, okay? So in this case, we have a square. This is the top view of our square here, okay? So we have the current moving through our wire, right? And then we have our L, right? This L value here on both sides. And then we have this R value here, right? So notice for this, because we have a square, our R is actually going to be equal to our L. And we have a W that we're given for our width. So we're modeling this L as W over 2. So L is equal to R, which is equal to W over 2, because we have a square. So the distance to the wire is R. The length of each side is 2L, okay? So we're going to go ahead and plug those values in to find the B field just due to one wire. But in this case, we have 4 sides. So 1, 2, 3, 4, 4 sides, 4 wires. So we're just going to multiply our total result by 4 in this case, okay? So for reference to, if you forget where the L and the R is, so the R is just bisecting this wire kind of in the middle, and then this L value is here. Okay, so multiplying by 4, plugging in W over 2 for L here, for R here, L here, and R here. You can see that. This last part here is just some algebra. Please feel free to work through that part on your own. I just kind of want you to get the higher level conceptual understanding of what we're doing. And we simplify and solve. And then the last piece that's really important is our direction. So we modeled our B field as going in the phi hat direction, right? Because just relative to each wire, it's just rotating around those wires, right? So we know that it's, oh, wrong color, right? So it's just rotating around those wires. But in this case, we're measuring at the origin, right? And we want to know what's our resulting B field here at this origin point. What is it? Well, because we have these rotating B fields, right? So the thumb is always in the direction of the current. So our current is going here, going this direction. And the B field is rotating, right, coming around, right, these wires. And essentially in the center of each of these, the B field is going to be pointing up, right? So rotating. Just using the right hand rule here, right? So our thumb in the direction of current and the B field. So it's curling up at all of these points, okay? So when we're in the middle, the resulting B field is actually going to be pointing in the Z hat direction, right? Because even as we zoom out, these B fields are kind of radiating out, right? And so the sum of them radiating out to the middle is going to be equal to this vertical Z. So at this point, the force that we're experiencing is going to be in the positive Z hat direction. So hopefully that makes sense, even though my drawing's not really the best here. I will show it again in a couple of problems later on, so maybe more examples will help it click if it doesn't make sense to you right away.